So today's lesson starts off being about eye level. And what I want you to do, so we can get that to make sense, is I want you to make a horizon line similar to usual, maybe about 2.5 inches down, nice and horizontal across your paper. There's no rule in perspective that your horizon line always has to be in the same place. But for our lesson today, that's where we're putting it. And let's go ahead and put a vanishing point about the middle, kind of like we did before. Okay, now this lesson is going to primarily live on the left side of our paper, okay? And then we'll be progressing the lesson to do some things later that are more in the middle of the paper, okay? So I'm gonna work on this side. What I'd like you to do is over here, way on the left, I want you to put an oval. This is a head shape that overlaps the eye level, okay? And I'll put a couple little eyes on it like that, right at the eye level. And you might be wondering, well, why do you put the eyes right in the middle of the oval? Well, a lot of people don't realize that if you're looking straight on at a head, the top of the head to the eyes, if you're looking at me, is the same distance as your eyes to your chin. And we don't think about the hairline much and the forehead, but it is actually in the middle rather than, say, the upper third, okay? So we have just made a head. Now, what we're gonna do is we're gonna make a body for this head. Not a super realistic body, but we're going to make what I call a proportional figure, okay? Proportional means how tall is the figure compared to the figure's head. For example, the top of my head to the bottom of my chin is a head length for my body. Now, that's one head length. 2 head lengths to the sternum, 3 head lengths to the navel, 4 head lengths to the bottom of the hips. Another head length to the middle of the thigh, then the knee, and then 2 more to the ground. So the average adult male is 8 head lengths tall. Biological females tend to be 7 to 7.5 head lengths tall. Normally their torsos are a little bit longer, okay? So we just want to be in that ballpark. So here's what we have. I have a head length, you have a head length. So if I take, this is 1 head length, 2, 3, 4. So find 4, like I just did. And then make kind of a long oval. This will just represent the body all the way down. Now, top of the head down here, that's 4. So if I make another long oval about that, around that same length, I can do 2 of them. These are going to be like the legs. And then I'll do a couple little sideways ovals to represent feet. We're going to create this diagram to just kind of make a few things make sense in terms of how you create the illusion of a consistent eye level in a drawing. Okay, so we have this figure, okay? The figure is standing right here. Let's make like a little line, kind of like a shadow line or something right under their feet. And here's what we're deciding for this drawing, that the eye level is 5 feet. The eye level of the viewer or the artist, that's me and you, right? Okay, the horizon line is our eye level. Anything above the horizon line is over our head. Anything below the horizon line is beneath our head. And anything that overlaps it is right in front of our head, okay? So we're gonna say that this eye level is 5 feet. So that means the eyes, and you're gonna draw and write what I write, okay? The eye level, do one of these down to the feet, we're gonna say is 5 feet in this picture, okay? If we're agreeing that it's 5 feet in this picture, that's gonna speak into other things in the drawing. Okay, so now this is actually where the lesson starts, believe it or not. Right about here, I don't want to get too close to the middle. Let's sort of stay over here on the left. Let's make another head, a littler one. Maybe that big. A little head overlapping the eye level still. Now, however small you make your head, I want you to make a properly proportioned body, just like we did before, that matches that head. Okay, so here's what we know. The head is overlapping the horizon line, which is our eye level. And this figure is standing right here, further away from this figure. And because the head is at the eye level, look at this. The eyes down to the feet are 5 feet. I'll zoom out so that has a little bit more context. Both of these figures are the same height. Their eyes are at the same height off the ground. It's just that this figure is closer to us in the foreground, and this figure is further away toward the background. Does that make sense? Okay. The height of this figure has nothing to do with the height of this figure. This is its own unit of measurement in the foreground, and this is its own unit of measurement farther away. Let's kind of drive this point home. What I want you to do is, however big you drew this smaller figure, I want you to redraw the figure down here, except the feet are going to be corresponding together. You see? Now is this figure seeing 5 feet? Or is he more like knee-high almost of my figure there? So it's where their feet or the bottom of the object determine location. Is it closer to us or farther away? And then where the top is, the heads in this case, with respect to the horizon line, indicate how tall it is. Okay? So I wonder how tall this figure is that I just made. I could figure it out like this. The bottom of the figure's feet to the eye level, we know, right, is 5. So if here to here is 5, half of that must be 2.5. Half of that must be 1.25. So my figure is probably about 1.5 feet tall. Would you guys all agree? Which would be 18 inches tall. 1.5 feet. So my figure is 18 inches tall based on the fact that the eye level is 5 feet. Now, what if my eye level was 10 feet? Okay, well, that means here to here is 10. Half of that's 5. Half of that's 2.5. That would probably make it a 3 foot tall figure. You see? So it becomes a unit of measurement. Okay? You can think of it like this. If here to here is 5, then here to here must be. And it's just like kind of a test question, right? About math logic and things like that. Okay. Let's draw a figure, but let's put the head up here. And then however big you make that head, give it a properly proportioned body. But how tall did I just make my figure? Now, you probably made your figure a little different than mine. So on mine, here's how I figure it out. Watch. The bottom of the figure's feet to the eye level, the horizon line, is what? What is it?
5 feet.
5 feet. Perfect. So here's the question. If here to here is 5, then here to here must be, and I would estimate, well, 5. I could actually take my pencil like this and then double it up. So probably 10 feet is probably about right here. So I would guess I just made a 9 foot tall figure. Now notice how when I was figuring this out, I was ignoring all the other stuff. This stuff over here has nothing to do with this one because their feet are all at different locations, okay? This figure is further away than this figure. So I can't use any of this information to help me with that one. Now, these two I can because the bottom of them are side by side, okay? Let's write down here, let's make a 1 foot tall box. How would I do that? Well, first, I'm going to make a horizontal line that will be the bottom of my rectangle. So I'm going to make a 1 foot tall rectangle here. Go ahead and make a bottom. Don't do it in the middle though. We're going to add something there shortly. Right here is the bottom of my rectangle. And I want to make a rectangle 1 foot tall. So here's what I know. The bottom of the rectangle is right here. To the horizon line is 5 feet. Half of that distance would be 2.5. Half of that would be 1.25. So a little lower than that, I would estimate here would be 1. You see? So that helps me figure out how to make that rectangle. This is a 1 foot tall rectangle. And remember, this is how it lays out. If here to here is 5, then here to here is 1. If this is true, then this is true. Okay, so now I have a vanishing point. We did this lesson before. I'm going to make this thing 3D to the vanishing point to make it into a real box. And I'll cut it off horizontally there. Cut it off vertically there. So now I have completed the drawing of the box, and I know that this box is 1 foot tall. Side note, if here to here is 1 on my picture, then that same distance here would also be 1 horizontally. So I probably have a 1 foot by 1.5 foot box or rectangle. Okay, we're going to switch gears to a new lesson on the same piece of paper. Okay, and I was asking you to try to keep the middle clear because I'm going to ask you to make, from your vanishing point, pull a line this way and pull a second line from your vanishing point this way. And we can think of this as a path. Okay, it could be a road, it could be a river, it could be any kind of path. What we're going to do is we're going to treat it like it's a sidewalk. Sidewalks have lines on them, right? That make up all the segments of the sidewalk. Okay. Now, aren't most sidewalk segments the same? Yeah. Within the same sidewalk, of course. You know, sidewalks are different than other sidewalks, but on the same sidewalk, the lines would be equally spaced apart. However, we know that in 3D, those lines don't seem equally spaced apart. Don't they seem like those lines would get closer and closer and closer together? Okay, so we instinctually know that. But the question is, how do you know exactly where and how to draw those lines so that it's 100% true? That's what we're going to learn today, is how do you draw things that are the same size and equally spaced apart? In this case, it's a sidewalk, but it could be windows, it could be bricks, it could be parking spaces, it could be lockers, it could be lights on a ceiling, it could be monkey bars, it could be whatever you want that's the same size and equally spaced apart, okay? So in our drawing here, what I want you to do is very, very close to the bottom of the paper. I want you to make a horizontal line like this. Okay, that's going to be our first sidewalk line. And then what I want you to do is I want you to make an artistic decision as to where you think the next one should go so it looks good. So it looks like a proper sidewalk. So if I go way too far away, that's going to look like a really long rectangular one. If I go way too thin, that'll look more like a floorboard, right? I'll go right about here. The most important piece here is that it needs to be horizontal. It needs to be parallel to that line. So I'm going to make mine right there, and then I'm going to ask you to stop there for the lesson. Because the goal is we're going to make more lines, but I don't want you to have to guess where to put them. We're going to learn how do you do this without guessing. So I have this piece of paper I'm bringing into the mix, And all I want you to do is watch, okay? You're not drawing this with me. You're just watching because I need to establish a certain bit of logic with you. I'm going to draw on this piece of paper before your eyes. I'm going to make simulate a sidewalk that's not 3D. I'm just looking straight down on a sidewalk path. You guys see that happening? So this is the sidewalk. I'll make a sidewalk segment, like a line right here. You are not doing this with me. You're just watching, okay? And I'll make a second one right here. And I'm trying to make it perfect, but I'm only human. But here's where we're at. Let's assume that I want to make more sidewalk lines, and I want them all to be the same. Now, in this mode, it would be really easy just to measure and then mark the lines, right? But let's say I don't have the ability to measure, okay? What are some other logical ways I could do that? So here's a question I have for you. If I were to start at this corner down here and aim like an imaginary line directly through the middle of the next one, like this, wherever it hits right here, wouldn't that be my next one and they would be identical? Yeah. Okay, so I gotta find the middle, but I can't measure. So what if I do this? Corner to corner, gentle line, X, guideline, and then corner to corner this way to complete that gentle X guideline. Isn't that X the exact center? Yeah. Okay, so now if I put my pencil right there and pivot my ruler and eyeball that my ruler is indeed straight and make a guideline, isn't that the center of my sidewalk all the way? Mm-hmm. So I've got the middle of this figured out because of this guideline. So now I don't need that X anymore. I could erase it, right? Okay. I'm going to take this corner, aim it through the middle of the next line with my ruler, and I'm going to make a dotted line just to indicate that to you. See? Now look, wherever it hits here, that's my next horizontal line, right? And these are identical if I don't have any human error involved. So now if I take this next corner of the new sidewalk square and I repeat that through the next line, wherever it hits here is my next line. Now, as you get better at it, I could just kind of skip to that point, right? There we go. So these are all, in theory, they're all identical, and I didn't do any measuring with my ruler to achieve it, okay? So let's come back to our picture here, and we're going to put this into practice. Now, this doesn't matter if my sidewalk is centered or over to the right. It doesn't matter. Let's first find the middle of our sidewalk segment by doing that gentle, accurate corner-to-corner X guideline trick. So there's my X. That's the center. Now, what do you do with that X? You take the middle of it and you aim it exactly at your vanishing point. And you pull a gentle guideline. And that gentle guideline represents the middle of my sidewalk forever as far as I can see. Now, I don't need that X anymore, right? I could erase it a bit. I don't want it to complicate matters for me. Okay, so now let's do our trick. If I take this corner, it could be either direction, but I'll go lower left. If I take my lower left corner, aim it exactly through the middle of that next line where the guideline passes through it, I'll do the dotted line just like before. That look, wherever it hits right here must be the next horizontal sidewalk line. Now, be careful, keep it horizontal. Don't let it get tilted on you, okay? Now I can repeat it. I can go to this new corner of the new second sidewalk segment, aim it through the middle of the new line, and look what's happening right here. Gives me my next line, and they're gradually going to get closer and closer together. Now I can go through my new one, and I can keep repeating it. like that. Now, once you understand the system, I could just do this. Line it up, skip to that point, pivot horizontal, and draw. Then go to the next one, skip through that point, pivot horizontal, and then draw. Now, what I like to do is the further away I go, I like to draw lighter and lighter and lighter. One error that beginners make right here is their ruler starts to get tilted and crooked. You got to really pay attention to keeping your ruler straight and horizontal. At some point right here, things start to get so close together, in real life, you wouldn't even be able to make them out. So when I get that far like that, what I like to do is this little illusion. I start up there and I do some shading horizontally like this. And I shade back into it like that. You see? Clean up my shading on the edges there. And now it creates this illusion that the lines get so close together off in the distance that I can't really make out them individually. I want to show you two cool things based on what we've just done here. First, rotate your paper 1/4 turn like this. And it's windows, it's lockers, it's bars, it's whatever you want them to be. It could be a fence, it could be light poles that are going further away. Turn it upside down. It's monkey bars, it's lights on a ceiling, it's tiles on a ceiling. You're looking down a ladder. It's whatever you need it to be. Anything that's equally spaced apart and the same size. Turn it this way and we're back to something vertical. Okay? So I did not just teach you how to make a sidewalk. I taught you the fundamental of how do you draw things that are the same size and equally spaced apart. Now, I want to show you something else that piggybacks off of a lesson from before. Remember when we made the grid drawing? I'm going to grab a student's picture here. Remember when we did this activity, and we made this by putting this other dot out here on the end and making those connections? Look at my 3 dotted lines here. Where do they actually go to? Look at that. They actually follow to another dot. You don't have to draw it, but I just want to indicate to you the connection to what we learned before, where sometimes there are other points of interest out on the horizon line that help you figure that out. And every one of these points, in theory, right, they would all connect to those angles. To continue this lesson, we're going to go to another phase on this side. So if you have what I have with these kind of bonus lines that I made, I'm going to go ahead and erase those just to get them out of my way. If you don't have them, then good for you. I'll move this too. Okay. All right. Okay, so what I want to go over with you right now is a little bit of a piggyback off of a previous lesson where we did this grid right here. Does this ring a bell? The way we did this grid is we followed official scientific linear perspective strategies where we made this horizontal line and marked it every 1 inch. But to make it into a grid, we aimed each point to the vanishing point to create the rows. But to go this way, we made another point on the horizon line out here, and we made all these connections to indicate where all of these lines should go so it looks like a realistic grid. That's the official way it's done. However, it's not that easy every time you want to make a grid to figure out where to put that other point out there. And I'm going to get rid of that one there too. So I'm going to show you a little bit more of a user-friendly way to draw grids right now. Okay, so I'm assuming you have some space down here on the lower right. Down here in the lower right, see if you can find room to make a 5-inch line. I'm really squeezing it in there. You see that? It's a 5-inch horizontal line, and I'm going to mark it every 1 inch, just like we did before. If you can only fit in a 4-inch line, that would be okay, but I think 5 inches has a good look to it on as far as this grid goes. Okay, now, just like the other lesson, what I want you to do is take each of these points and accurately connect them to the vanishing point. And you can, the way you do this fast is you pivot off of the vanishing point. So I pivot, draw to the point, and I draw. Then I pivot to the next point, put my weight down on the ruler, and I draw. And just keep doing that. The angle is going to get more extreme, and that's okay. This is the point that we want to get to. And remember, these can be anything, right? These can be floorboards. They can be rows or lanes of any type. It just goes to show that everything doesn't have to be down here in front. Things can be off to the right, and things can be off to the left. All right, we're going to turn this into a grid just like before, except we're going to deviate from the strategy that we used last time. Last time, we would have put a point somewhere on the horizon line, and we would have made all those connections, right? We're going to do it an easier way now. What I want you to do is make an artistic decision. Where do you think that first line should go so it looks like a nice little row of squares? So use your judgment and figure out where do you think you should put that first line so that it looks like a decent set of squares. I'm going to go right there, there to there. Okay? And once you get there, I want you to stop and pause. So now the question is, where do the rest of the lines go? And I asked you to make an artistic decision to make that first line because we're going to use it to figure out the rest. The best way to do it is to look at one of the end squares. I'll zoom in a bit on this, okay? All right. So this end or this end, this square looks a little bit more easy to work with. So here's what I'm going to do. I'm going to aim a guideline from this corner directly through the opposite corner, like this, except keep going all the way back. See? Just like that. So I'm going this corner exactly through this corner, and then I'm just going to continue the line. And when you do that, it gives you a set of intersection points that are useful. I have one here, 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 and here. Those intersection points tell you exactly where to put all the other lines. So I put my pencil on this intersection point, and I'm going to pivot my ruler so it's nice and horizontal. And then I draw the whole line. Then I put my pencil on the next intersection point, pivot my ruler so it's nice and straight and horizontal, and I can draw the whole line. And you just continue that until you've gotten to the back. Now, the mistake students make a lot is they start to make their ruler tilted by mistake. So try to focus on that, keeping your ruler straight. If you don't, it can ruin the illusion. You do what I do.
Just like everything is.
Okay. I don't want to keep going, but suppose I did want these lines to keep going. Couldn't I just repeat that using this square right here? So I could go this corner through that corner, like this, and then it would give me a whole additional set of intersection points where I could keep it going, couldn't I? All right. Now, I don't actually want to keep it going in this exercise, so I could now erase all of my leftover orthogonal lines. Okay, side note, Remember on this first one here, right here, we gave that thing thickness by adding that little rectangle to the front. We can do that here. So I'll go to the front and I'm gonna add a little rectangle just for fun. And that gives it thickness. But guess what? It's a little different because now I would see the sides. So I can take this corner, new corner to the vanishing point and then put a little cutoff right there. And that makes it look like it has thickness here and on the side. So let's revisit this in a different way. This time, I want you to make a 5-inch line over here that's nice and vertical, wherever you want, but just let's go a 5-inch line and then do the same thing, mark it every 1 inch. The only difference is this is a vertical line instead of a horizontal line. Once you have made your 5-inch line, marked it every 1 inch, we're going to do the same step of connecting each point to the vanishing point. Now, my horizon line is kind of complicating matters here if I want to assume that this is solid. So I could erase that horizon line right in there. We're going to go ahead and turn it into a grid just like we did this one, except now we're working vertical. So you're going to do the same thing. You're going to put your first vertical line where you think it would look best. And I think mine would look best right about there. Make sure that ruler is nice and straight, parallel to your original line, and pull that first line. Then we'll do the same strategy we did before, where we go through one of the squares corner to corner. You can either go from the bottom or the top. You could go top downward or bottom upward. It doesn't actually matter. I'll go from the bottom. So if I take this corner and I aim through its exact opposite corner with the ruler, I can draw a light guideline all the way. And just like before, that gives me a set of intersection points here, 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 and here. And then I can translate those into the rest of the vertical lines. So I put my pencil right there, pivot my ruler so it's nice and vertical and straight, and draw the whole line. Put my pencil on the next one, pivot my ruler so it's nice and straight. I think I'm starting to get a little crooked though, so forgive me. Sometimes the human error is just unavoidable, but it's important that we understand the logic of it all. So now I have this vertical grid. If I want to, I could then erase my orthogonal lines. And I suppose if I do that, I would want to draw my horizon line back in, unless I plan to add more stuff. So now I have this vertical grid. But listen, couldn't I turn this into a box? What if this part here is facing me? I just go to the top and put in a horizontal line going off the paper. And I'll go to the bottom and do the same. And this initial line right here, I'll make it bold because it becomes like a real strong corner, right? And if I wanted this grid to seem like it was wrapping around the box, I can just go to each of these points and add a horizontal. And just like that, it looks like I have kind of a grid box going off the side of the paper. If you're drawing buildings, if you're drawing windows, if you're drawing things that are horizontal, things that are vertical that involve a grid, this is most likely going to be the strategy that you use to do it accurately.